Hi, in this video we are going to see how to make a very simple MIDI controller using 4 potentiometers, 4 buttons and a Teensy 3.2. So we will start by the potentiometers. We will have to read each one of them. If you don't know, the potentiometer's value range is from 0 to 1023. And we will need to shrink these values to comply with the MIDI protocol, which is from 0 to 127. We will see that the potentiometers have electronic noise, so the reading will fluctuate, and we will see a very simple way to reduce this fluctuation. So let's start. Okay. I will start defining a number, and this number is the number of devices I have here. And now I'm going to define an array, and this array has a length of 4 devices. And I know that the potentiometers are connected to the A0, A1, A2 and A3 on the Teensy. And now I'm going to name another variable called potentiometer raw value with the same length. This array will contain the values of the potentiometers. Okay, so here on the setup I'm just starting with the serial begin. Here on the loop I will have a for function, and now I'm going to read each one of the potentiometers. And now I'm going to print each one of these values. No. Okay. And now we can see that we have our readings. Okay, so this is the power of the array. As you can see, I have the 4 devices here, the A0, 1, 2 and 3. And with this for function, it's also called a loop. So I am constantly looping each one of these pins, of these inputs. With the 0 here, the I letter is replaced with a 0, and I am going to read the pot pin 0, which is the A0, and then I'm going to print the pot raw value 0, and it outputs this number, and then it will cycle again, and it will add 1 here to the I, and now it's 1. So it's pot raw value 1 will read the analog reading on pot pin 1, and it will print pot raw value 1, and so on and so forth until it reaches the total, which is 4. It will go back to 0 again. If we didn't use the arrays, we would have to read individually each one of the potentiometers, which in this case it would be okay because they are only 4, but if we have 8 or 16, it would be really a pain to do that individually. Now we need to shrink this range of values to the MIDI range 127. Let's make here something like a variable pot mapped. Okay, and it's another array, and now pot mapped I is equal to map the raw values, and this is the minimum and maximum input, and now this is the minimum and maximum output. Okay, and now I can also print this like this. Let's see. Okay, So we can see that each one of the potentiometers, the left column is the raw and the right column is the mapped value. Now, another issue that you might be noticing is there is some fluctuation going on here. Depending on the position of the potentiometer, sometimes it's steady and other times it fluctuates a little bit. And we can also solve that with a simple function. Again, I will make another array, and this time I will call pot smooth with the same numbers. I will call it pot smooth, and here this is what we are going to do. So pot smooth is equal to itself times 1.0 minus a filter, and the filter is the amount of smoothness we want to add. Let me also add here a pot filter, like 0.1, and here, okay, and now plus the original value that we want to smooth times pot filter. Now again, let's print this guy, pot smooth, and let's see what we have. So as you can see, we are adding columns, and we can see that the value is okay, but as we increase, okay, I don't have 128. For this, I will add another decimal. Okay, like this. Okay, we are 126. If we want to go to 128, let's see, 126, okay, 127. And as you can see, there is fluctuation here, but this one is perfect. Okay, so now we are ready to send our MIDI messages. What we need to do now is, if I start sending MIDI messages right now at this point, I will be constantly spamming this value, and this will cause lag on the software, and we don't want that. We just want to send a MIDI message every time this value changes. Let me hide these prints. Okay, and now what we are going to do is I'm going to create another array called pot previous, and the same way it will be the same size of the other arrays. And now I'm going to compare values. I'm going to compare an actual value with a previous value, and you will see what I mean by this. So here we will compare this value, pot smooth. Okay, I'm going to copy. I'm going to see if it's different from this guy here. And if it's different, I'm going to print it. Okay, and like this. And then I need to update the pot previous with the actual value. Let's see. So I don't have nothing coming from the serial port, and every time I turn the knob, there's a value coming in. This is what we want. And now, finally, we can send our MIDI message. This is the command, send control change, and control change has an index, so this can be the index 1, and then this is the value. So we want this value. And finally, we have the MIDI channel. Okay, and notice that I am not printing anything. We want this to be as optimized as possible. Now that we have the MIDI message programmed with the USB MIDI command, we need to make the Teensy to be recognizable as a standard MIDI controller. For that, we need to select in the Tools menu, in the USB type, Serial plus MIDI. This makes possible to print serial messages on the console at the same time that we send MIDI messages. This also makes the Teensy to be recognized as a generic MIDI controller by software and by compatible hardware. What I'm going to do now is I'm going to open this monitor, and as you can see, messages are coming through. And now I'm going to open Ableton Live. I have 4 tracks here. And now, to add MIDI, I will select this guy here and I'll twist this knob. I select this and I twist the second knob. I select this and I twist the second knob, and I select this and I twist the second knob, and then, so this is called the MIDI learn. Everything becomes this bluish purple color. And here we can see a list of the control change index, the index that we stated in the Arduino, and what is it going to modulate. And now I have assigned these MIDI messages to the faders. Okay, so that's it. In the next video we will see how to work with the buttons to make them toggle, for instance, the enable of tracks in Ableton Live. Okay, so see you in the next video.